In this video, we're going to solve the functional equation a(f of x plus b(f of y) equals f of ax plus by. So the first thing we're going to do is take the partial derivative with respect to x on both sides. Now why partial derivative? Because we're dealing with two variables, x and y. And the partial derivative of anything with just y is 0. So this will just be a(f prime of x. This part will go to 0 because it doesn't have x in it. So this will just be f prime of ax plus by multiplied by the partial derivative with respect to x in the inside, which is just a because we have ax. So for case 1 is a equals 0 because then 0 equals 0. So let's plug that into the original equation. So that will just be 0 times f of x, which goes away. We have b f of y equals f of ax will go to 0 because a equals 0, and we have by. Okay. So we're going to let by equals 1. So this will just be f of 1, and that's a constant, so that's easy. So let's solve for b. So b equals 1 over y. So now we have, so b is 1 over y times f of y equals f of by, which is just f of 1, which is a constant. So now multiplying by y, we get f of y equals c times y. So that is the first answer we get. The second answer we get, so if a does not equal 0. Okay, so now we can divide by a on this, leaving us with f prime of x equals f prime of ax plus by. Okay, so now we want this to be a number, so let's just let x equal 0. And we also want this to disappear, so that makes sense that x equals 0. So this will be f prime of 0 equals f prime. This will go away because it's 0, and this will just be by, which f prime of 0 is a constant, so we can do the derivative with first we can do a substitution. Let z equals by, the inside, so it looks simpler. So we have f prime of z equals c. So now we have f of z will be c times z plus, so let's say this is c1, so this will be c1z plus c2. c2, not z2. Okay. So now if we substitute in back to by, it'll just be another constant. So this is our second possibility. This is our first possibility, right? But now we can substitute this back into the original and see what we get. So the original is a f of x plus b f of y equals f of ax plus by. We can substitute this into here. Okay. So we're going to get a f of x, which will be c1 x plus, now we have a c2, and then plus b f of y, which is c1 y plus b c2. Okay. So these are in parentheses just to show where they're coming from, equals. Now we're going to plug in ax plus by into here. That'll leave us with c1 times ax plus c1 times by, and then we have plus c2. Okay, so that almost works. So we have ac1x and ac1x, that will cancel. We have we have bc1y, bc1y, those will cancel. Now we're going to group them together, so we have a plus b times c2 equals c2. So another thing is c2 equals 0. So that just means we have f of z equals c1z, but we already have that. So f of y equals cy. So we have f of y, or just say f of z equals cz. That's our first case. Our second case, for this to be 0, is a plus b equals 0, right? Because if this is equal to 0, if this cancels, if c2 is not equal to 0, so if c2 is not equal to 0, then we have that a plus b equals 1, sorry, not 0. Right, because if these are canceled, you just get a plus b equals 1. So that means that we can use the original equation, which is f of z equals c1z plus c2, and the other possibility is a plus b equals 1. Okay. So that's our second possibility. So f of z equals c1z plus c2 where C2 does not equal 0, and we have A plus B equals 1. So those are the answers, and that is the end of the video. Hope you liked it.